All right, guys. So EOC boot camp. We are back to number 35, finishing up the packet we were at before. The area of a trapezoid can be found by using the expression. So they've given us the equation where h is the height and b1 and b2 are the length of the bases. The trapezoid has a height of 12. So height of 12. And bases of 2x plus 3 and 3x plus 1. Which expression represents the area of the trapezoid? So again, we're using our formula. 1/2 times our height, which it says is 12. And then it's B1. It doesn't matter which one since we're going to add them together. These are just combining like terms. So you're just putting together things that match. That's all we can do for now. And 1/2 of 12. So we have 2x and 3x. That gives us 5x. And then we also have 3 and 1 constants. So that's plus 4. All that's going to still be in parentheses. And then 1/2 of 12 is going to give us 6. And then we have to distribute. So 6 times 5 is going to give us 30x. And then 6 times 4 is going to give us 24. So 30x plus 24. Our answer should be C. Hopefully you guys gave that one a try. Most of these, it's really they're going to give you the formula. So if you think back to function notation or just substituting in, they'll give you what the variables stand for, and then you just have to plug it in and use your polynomial operations to solve. So number 35 done. Number 36, the expression negative 16t squared plus 32t plus 64 models the height of a rocket in feet t seconds after its launch. What does the 64 represent? So lots of fun things, kind of like back when we were doing linears. That is still a constant because there's no variable attached. That is also going to be your y-intercept, also known as your starting point, because again, it is a constant. It is just a number. It is a term with no variable. Sorry for my R losing its R. So what the maximum height of the rocket, that's not something you're going to tell just from the given equation. That's where you could either graph it and go max height is going to be the y value of the vertex. In this case, it would be a max or a min, and then the height would probably be max. Maximum is going to be max. So that means it's going to be a negative quadratic. So that y value of that point there. The speed of the rocket when it was launched, the height of the rocket after 64 seconds. So that is when you put 64 in the place of t and then get your output. And then the height of the rocket when it was launched. So when it started. So that's your starting point, where you started. When you graph it in Desmos or in a calculator, you're going to see a full parabola. But where it starts, when x is 0, so when there's 0 seconds, then you're going to have 64. So that's the starting amount for that problem. All right, moving right along to number 37. What is the equation of a line that is parallel, so a little different this time, parallel to 6x minus 2y equals 4 plus 6y and passes through the point 8, negative 16. Oh, wow, so off screen, sorry. So we have 6x minus 2y equals 4 plus 6y. And the important word is going to be the word parallel, which means we have the same slope. Parallel lines have the same slope. We're going to isolate y because we need to get this in y equals mx plus b. I'm going to move y to this side because it'll make it positive. So add 2y, add 2y. 6x equals, these guys are gone, 4 plus 8y. I'm going to move the constant over there with our x value, sorry, mx, and then our negative 4 is going to be our plus b. So it's going to be minus 4 equals 8y. Divide by 8 because that's the inverse of that multiplication. And so we're going to reduce, always reduce because we're in high school math at this point. 6 over 8 will reduce to 3 over 4 because they're both divisible by 2. X, 4 divided by 8 is going to be 1/2 equals y. So our slope is 3 over 4. We want it to be parallel, so we're looking for the equation that has a positive 3 over 4 slope as well. Negative 4 over 3 would be perpendicular because it's the opposite and reciprocal, opposite and flip. Negative 3 over 4 is going to be opposite but not reciprocal, so it has no relationship to this line. 3 over 4 positive is going to be parallel because it's the same slope, which is what we're looking for. And then 4 over 3, that's your reciprocal, but not opposite. So again, no relation at that point either. as far as to the conversation we're having right now. Moving right along. Number 38, Patrick graphed a square with an area of 50 square units on the coordinate plane. One of the vertices of the square is located at 5, 10. So we're going to use our graph. Remember, you're not going to have necessarily a set graph. You're going to use your large graph paper. You're going to fold it down so it's not overwhelming. And you're going to double count it to make sure you don't mess up, because all those tiny squares can make it a little daunting to make sure we get to the right number. So remember, this is X and Y. So we're going to go to the right 5, 1, 2, 3, 4, 5, and then up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is our first point. And then we want to find the other ones. So to have an area of 50 square units and being a square, that means X squared, or length times width, is equal to 50. So it's going to be the square root would be the length of each side, if that helps you at all to visualize what that is. So that means it's going to be a 7.07 side length. My best guess at that rate is that it's not going to be a flat square. But we're going to try our points. So 8 and 14, 5, 6, 7, 8, 10, 11, 12, 13, 14. This is a 4 by 3. So 4 squared plus 3 squared equals C squared. And we can just check that one alone. If it doesn't give us a 7.07, we know we're done. So it's 16 plus 9, which gives us 25. And the square root of 25 is 5. So that side length, if we were to use the 814 to make this our side length of our square, is not the right length. We're going to go on, move on down and go 10, 5. So 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. And that's a 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So 5 squared plus 5 squared equals C squared. It's going to be 25 plus 25. That's that 50 we're looking for. Because if we were to square root both sides, that means our side would be 7.07, or C squared, which is where we were here, is equal to 50. So that one looks good. We're going to try 5, 0. 5, 0. That's a 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. It's going to give us the same math. Perfect. Last but not least, 0, 5. And I'm going to check this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one looks really good. Just for conversation's sake, I'm going to check 10, 6 definitely won't work if 10, 5 did work. So 8, 10 relative to our first point here. 8, 5, 6, 7, 8, all the way up to 10. That's a side length of 3, so that's not going to work either. So our answer is B. So again, your starting point to make sure you're in the right place is knowing that an area of a square is X squared, which is where you would get to your Pythagorean theorem and how it would all sort of using distance between those two, the 4 points in this case, to make a square. All right, the table below shows the average price of new smartphones in X years after 2012. The data set has modeled with the linear best fit function. What is the meaning of the slope of the function? So this is where we're going to go to Desmos. You're going to start a table because this is line of best fit. We're going to start a table. You're going to type in your numbers. So 0 through 8. I'm going to come over. It is not a perfectly linear, and you know that because it said line of best fit. Once they're all in, you do want to double check and make sure your terms are all correct and they all match so it's actually on your paper or on the computer when you're doing your problem, because a small change will absolutely throw the whole thing off. This is where we're going to do y sub 1 tilde mx. We want that sub 1, or you can copy it from the table up at the top to get it where the one's in the basement. But if you're missing those ones down there, you're not going to get what you need. Our slope is 56.4. And then our starting point is going to be 311. So slope is 56.4. Our M value and our B value is 311.16. I'm going a little extra in details when I write it down on my paper, and we'll come back to this. So looking down here, we know that 311.16 would be the predicted from our rule. This is the actual, this is the predicted. There are going to be some questions along the way that might pop up that ask you, like at 6 years, how far was the actual from the predicted, or what was the predicted amount at 6 years, and then what is their difference? And that means you're just going to use the y equals 56.4 x plus 311.16, and you're going to plug in the 6 there to go see what the predicted amount is, because the actual is 679. And then again, getting this information is right in the equation. It's also known as getting the rule or line of best fit, as far as our vocabulary run through. The cost of a new smartphone increased approximately by 311 each year. That is mixing up your y-intercept and your slope. The cost of a new smartphone increased by approximately 56 each year. Approximately is where they got rid of that decimal, so that one's looking good. The initial cost of a new smartphone was approximately 311.16. Yep, that is a true statement, but it is not referring to the slope like the question is asking us to. So this is true, but doesn't answer the question they asked. The initial cost of a new smartphone was approximately 56. So A and D are not even true statements. The difference between B and C is answering the question they asked. So don't get confused. Just go back and read that last line and see where you're at there. All right. Number 40. Pause the video, guys, if you didn't take time to do these. Because definitely trying them, you need to catch your mistakes before you make them. You need to catch them. You need to make them. If you don't make them, then we end up with, we don't know what's going on, and that's not going to help us, because you'll make the same mistake repeatedly. So 41. Edgar recorded the total amount of money he had saved at the end of each month. He models the data set with a linear best fit again. Approximately means we're making a rule. So you're going to go back to Desmos. Again, there's no way around this. This is the only way you can get a line of best fit. You could do it in your TI-83. If this is already in your Desmos, I'm not sure on test day if it will save. I'm going to delete my table. I'm going to add a new table, and I'm going to go change that 2 to make sure it's a 1, and make sure that 2 is also a 1. If you wanted to address it without changing it there, you can change the 1s in your Y1 tilde MX1 plus B to 2s, and then it would know to use this table. So we have 1, 2, 6, 9, 12 as our input values, 35, 47, 188, 210, and 378 as our output values. Input, output. Y is dependent on our independent value of X. And again, we now see it automatically did it. The Y1 matches the Y1 on the table, so we know we're doing that right. And it wants to know how much will it save after 10 months. So with our rate of change being approximately 29.5, and then our starting point being a negative 5.26, or 5.3 if you want to go there, or we can even maybe round to whole numbers. We'll see which answer choice we've got, because it didn't actually tell us. I like to be a little over accurate and then round my answer. So we're going to take our equation and we're going to plug in a 10. 29.5 times 10 minus 5.26 is going to give us 295 minus 5.26. So it should be somewhere around 290, which is going to be approximately $289. This is not one of the ones where we could do one of these, because it's not constant. It is when, as soon as you see the word best fit function, then you have to go put it into Desmos. And linear gives it away while you're using the y mx plus b versus a quadratic or an exponential. It will usually tell you right in front of the best fit function for most questions what style to plug in. What is the area of the rectangle? Area of rectangle, so we have a binomial times a binomial. So we're going to have a mess when we're done, not a whole number. So 3x minus 2 times 2x plus 6. You have to multiply these together. So you can use box method. You could use FOIL. Distribution is another way they call it. So 3x times 2x is going to give me 6x squared. 3x times 6 gives me 18x. Negative 2 times 2x is going to give me a negative 4x. Negative 2 times 6 gives me a negative 12. 6x squared plus 14x minus 12. 6x squared plus 14x minus 12. They just added the two together, which is fine, but not helpful. If it had asked for the perimeter, remember that in a rectangle, our opposite sides are congruent, and perimeter, you would add them all together. So area of a rectangle is length times width. Hopefully at this point we know this. I feel like we've done a ton of these, but just making sure for those of you, if you pop into this one and haven't been to many of our boot camps, that might be a reason. So number 43, we're going to solve it. Definitely pause the video right now if you haven't done this one. This one is looking very familiar to me too, but I've looked through a gazillion EOC questions at the moment. But hopefully we haven't done it yet. If we have, practice it again. Don't cheat. Do it on your paper. Do it without a calculator. So go try this guy with no calculator. We're going to take that -3 and we're going to distribute it. So 6 minus 12x. -3 times 5, -5 is going to give me a positive 15. Because we have to multiply first. So it's going to be 6 minus 12 and then plus 15 equals 7. We're going to combine like terms. They're on the same side of the equal mark, so we're not doing inverse. We're just cleaning up, as I like to say. And then we still have our -12x on this side plus a positive 21 equals 7. We want to get 12x by itself. Subtract 21. -12x is equal to, we're going to divide by -12, divide by -12, and x is going to equal a positive 7 over 6. That is a very fair game question for them to give you calculator inactive. The double negative, remember, is a positive. It could be 1 1/6 as well. I'm trying to think of the other ways you can see your answers. Likely the answer is going to be in your fraction form as given if it happens to be calculator inactive. If it happens to be active, obviously it'll probably be a decimal answer choice. All right, number 44. A group of children, 3 children and 2 adults, pay a total of $120. We have children and adults to take karate class. Hopefully we see number, total, and you think system of equations at this point. And the way these are set up in this word problem, it looks like we're going to do elimination. We'll see when we get to the second sentence. So 3 children plus 2 adults is $120. Second sentence, a group of 5 children and 1 adult. 5 children, 1 adult. I'm trying to make this look like A's. For $95. What is the total cost for 1 child and 1 adult? So we're going to solve for A and C, and then we're going to get their total cost, which means we're going to add them together. We're going to find the sum. So which, remember, it means add. Again, just throwing out all these mathy words. We need to be able to find a matching set of numbers that are opposite. 3 and 5, we could multiply the top one by 5 and the bottom by 3 all the way through and make one of them negative. I can make this one into a 2 by simply multiplying the second one by a -2, so we have same numbers but opposite. That's going to give you a -10c minus 2a equals 190 negative. And then we're going to bring down the one we had before. And then we're going to work straight down and add. And when you work straight down and add, these are going to cancel out. -10c plus 3 gives you a -7 for children. And then a negative, I owe you $190, but I pay you $120. I'm going to owe you $70. -c is -c times c. The inverse operation of that is going to be division. So we're going to divide by -7. So -70 divided by -7. C equals a positive 10. So children cost $10. We need that plus whatever adults cost. So we're going to go plug that C in. You can pick whichever one you want. I like this one because it's going to be just A. So 5 times 10 plus 1A, otherwise known as A, equals 95. So that's 50 plus A. Now it looks like a 2. I'm going to subtract 50, so adults are going to equal 45 because 95 minus 50 gives us 45. So if adults are 45, add those together and I get 55. Hopefully that guy came together for you a lot easier than it did when we originally learned it, and we're feeling a little bit better because you can count on one of these. Very likely to be at least one on inactive and at least one on active. The one on active probably will have change. It'll probably be cost, so some decimals in it. Hopefully the one on the inactive will just be whole numbers like this one. So not necessarily, you have to stop and think, but you don't have to be able to use a calculator to get those numbers. All right, the function f of x, 5 times 2 raised to the x power. So that's an exponential function. Exponential function. represents the number of bacteria, f of x, growing in a culture after x hours. How many bacteria are in the culture after 3 hours? Another good call out is that 2 means it's doubling. It's a whole 1 more than we had to begin with. So 1 plus 1 in this case, because it's 100%. Move it 2, that gives us our 1, just for our thought process. Because remember, it's a 1 plus or minus the percentage rate as a decimal raised to time. So we're going to take 5 times 2 raised to the third power. Without a calculator, this is still a fair question. 2 to the third power, remember, is 2 times 2 times 2. 2 times 2 is 4, times 2 is going to give us 8. So this is simply 5 times 8, which gives us 40. Now we're done. Don't panic. Think about what you know. You know the math, guys. Definitely know the math. That would probably be very, very much an inactive question. 46, I'm going to feel the same way, is likely to be an inactive question as well. Let's work on that one. So we have a function f of x and g of x. What is the value of f of 2 and g of 10? So this is going to be function notation if you're looking for which lesson we were doing, and we're plugging in the numbers. That 2 is inside the parentheses, so it's going to go inside the function named f. So we're going to go find our Frank function, which is the 42 times 5, and we're going to raise it to the second power. Then the problem set here, we're going to subtract it from g of 10. So that means 10 is in the place of x. So we're going to take Gertrude function, and we're going to plug in 10 for x. So it's going to be 30 times 10 plus 12. And now again, so far, these numbers look like they're very much calculator active kind of numbers. 5 squared, remember that means 5 times 5, which is 25. So 42 times 25 minus 30 times 10 is going to give us 300, and we'll add 12. I'm writing it all the way out. 42 times 25, not nice if you didn't have a calculator, but doable. 5 times 2, 10. 5 times 4 is 20 with a 1 left over, so that's 210. 2 times 2, we're going to come in 1 is 4, and 2 times 4 is 8. So it's going to give us 1,050. So 1,050 minus 312. So minus 312. Depending on how your teacher taught you along the way, I'm going to borrow. 10 minus 2 is going to give me 8. 4 minus 1 is going to give me 3. That 0 is not going to work. So we're going to call that a 10. 3 from 10, it gives us 7. So it's going to give us 738 as our answer for that beautiful problem. Biggest call out is when the 2 is inside the parentheses, it goes inside the equation. If it was on the outside and f of x equals 2, then it goes on the outside in the place of f of x. If they were to put a number outside here or something, then you're going to still do the same thing. You're going to solve this one, then you would multiply it by 3. F refers to function f, g refers to function g. I think that's all the call outs and throwbacks for those guys. All right, last but not least, last but not least for this set, for this day, because I'm hoping you're doing these on your own as well. We're going to solve the inequality. 3x plus 5 is greater than 2 times x minus 7. Please, 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 if you did not already, pause the video right now and go try this and see where your mistakes are. So 2 times x is 2x minus 14. 2 times the negative 7 is the negative 14. We're going to get our x's together. So minus 2x minus 2x. I always like to work, especially with inequalities, towards the positive for our x values. Because remember, that's the golden rule of inequalities, is that if we have to divide or multiply by a negative, and that would be attached to that x, then we're going to switch the sign. If we can avoid that, then we just keep on rocking and rolling the way it is. So x is going to be greater than a negative 19. And we subtracted 5 because that's the inverse of addition. Subtracted 2, again, the opposite of positive, to move it across, in this case, not the equal mark, but the inequality sign, the line of great divide. So x is greater than a negative 19. I just looked at it at the time, and we still have time. So we're going to do one more at least. So the nearest whole number, what is the average rate of change for the function f of x over the interval 0 and 15. We definitely already did this one, and the answer is B. So we're going to cross this one out for now, and the answer is B if I recall correctly. If you find out that's not a thing, send me a message, and I will show you how to do that one. The easiest way, and I know we had a conversation about the average rate of change. Absolutely made complete sense to the conversation. But if they call out 2, just go grab those 2 and find the slope between those. So solve for 0, solve for 15, and find the difference in those. And that's where you should get that 1893 as well. Okay. All right, so moving right along, 49, we're going to finish this packet. Nice. And I will send out the new packet in just a little bit. All right, we compared the zeros of 2x squared minus x minus 10 to the zeros in the function graph below. Our zeros in the graph below is -1 and -4. What is the value of the smallest zero of the two functions? So we can make a list. I'll say we have a 0 of -1, a 0 of -4 for the graph one. This guy, we're going to factor it, or at least try. If not, you can go straight to quadratic equation. If you like quadratic equation better, we're looking for the zeros, which are the solutions, x-intercepts, and roots. So that will work as well. There's not a GCF, so we're going to just go ahead and get after this guy, or at least try. We're going to put AX in the corner, AX. A times C, so 2 times a -10. And then I need a -1 in the basement because that's our B value. B goes in the basement. We're looking for the numbers that we multiplied together to get a -20 that will add or subtract to give us a -1. So we have 1 and 20, 2 and 10, 3 is no good, 4 and 5 looks good. The next number will be 5, so we've got our sets. 1 and 20, 21 or 19, not going to work. 2 and 10, 12 and 8, not going to work. 5 and 4 will work. We're going to put the biggest number. I always like to put in the front. B is negative, so I know that first number has the larger number of 2 has to be negative. And then we're going to decide about the 4. If I owe you $5, but I want to only owe you 1, I am indeed going to add 4. Now, these are not fractions, but we're pretending. Can I reduce 2 over -5? No. So that means it is strictly 2x minus 5 is my first factor. 2 over 4, not fraction, we're pretending. That's going to become a 1 and a 2 because it is divisible by 2. And we need to leave it as a top part and a bottom part in our diamond because we need a front and a back in our factor. These are the factors. I've said this a ton of times in live class and in boot camp. Factors. To get to the zeros, the roots, the x-intercepts, and solutions, we're going to take both of those and set them equal to zeros and solve. 2x minus 5 equals 0. X plus 2 equals 0. I'm going to move that 2 over. Subtract because it's the opposite of that positive. So we got a -2 to add to our list. And we're going to add 5. We're going to add 5 because that's the opposite of the subtraction of 5. And then divide by 2. And 5 divided by 2 is going to give me 2.5. And that's a positive 2.5. So we're going to add that to our list. Which one is the smallest? They gave you a long list of negative numbers. Smallest means it's the furthest away from 0 to the left. So we're going to go -1, -2, -3, -4. So -4 is going to be our answer to that puppy. All right. Yay. If you have any questions, again, call out to be zeros. The other words to be roots, solutions, x-intercepts. This is when something hit the ground. When does the profit come back to 0? All right. Number 50, the equation of the line J is 6x plus 5y equals 3. The equation of Q is 5x minus 6y equals 0. Which statement is true about the two lines? Line J and Q have the same y-intercept. They're parallel, which means same slope. Same x-intercept. And that, just remember, we know that at the x-intercept, y equals 0. And then lines J and Q are perpendicular, which means opposite, reciprocal, opposite and flip, slope. They're both in standard form. To be able to answer those easily, especially without a calculator, you need to get y by itself. So I'm going to subtract 6x, and then I'm going to divide by 5 because that's the opposite of multiplication. So our first one is y equals a -6 over 5x plus 3 over 5. On our Q function, we're going to do the same thing. So we're going to Isolate y. We're going to subtract 5x. Subtract 5x. So that's going to be negative 6y equals a negative 5x plus 0. The y-intercepts are definitely not the same because we have a 0 here. So that one's out. I'm going to divide by negative 6, divide by negative 6, divide by negative 6. 0 divided by anything is 0. If it was divided by 0, we have a problem. That means that there's not a solution. It blows up. We can't discuss it. It's over. So this is going to be y equals negative negative gives a positive 5 over 6x plus 0. So this would be our next equation. If I'm going to look at our slopes first, they're definitely not the same. So parallel is out. They are opposite and reciprocal. 5, 6 is compared to negative 6 over 5. They flipped, and one is positive and one is negative. Yay. X-intercept, if I plug in a y and solved, that would be your x-intercept. So 0 equals 5 over 6x. Multiply 0 times 6, 0. Our x-intercept is also going to be 0 as well, because 6 times 0 is 0. And then divide that by 5, still 0. The x-intercept here is not 0. If I subtracted 3 over 5 over, multiply by 5, then divided by negative 6, it's definitely not going to give a 0. We have real numbers happening here. So C is a no-go. And I say real numbers, that's terrible because 0 is a number. We're going to go ahead and knock these out. Which expression is equivalent to x to the 6th power times x to the 2nd power? This is multiplication, so when we multiply, we add exponents. So 6 with like bases. If we multiply two terms with like bases, we add the exponents. So it's going to be x to the 8th power, or which one is equivalent? That means, so we're looking for x to the 8th power when I simplify. So 4, 5, 6, 7. This is going to be x to the 7th power. 5, 6, 7, 8. X to the 8th power. That one looks good. 7 plus 3 is going to give me x to the 10. And 9 plus 3 is going to give me x to the 12th. So it is definitely B, x to the 5th, x to the 3, gives us x to the 8th. Last but not least, pause it. Go try it. No calculator. Don't cheat. I'm going to move my big X to try to make it positive. So I'm going to add 3x. Add 3x. And that's going to give me 2. Plus 2x is less than 4. I'm going to subtract 2. Subtract 2. 2x is less than a positive 2. If I have 4 and I spent 2, I have a positive 2. Divide by 2 because it's the inverse of multiplication. That is a positive, so we're good to go. So x is less than 1. If we had moved it the other way, it would have still been exactly the same. We would have, in the event you chose to do it that way, add x, subtract 4. Subtract 4. See, negative 2 is less than a negative 2x. Divide by a negative. And that means we have to flip our sign. So x is less than a positive 1. Same thing, just flipped. So again, the exact same answer. They're just written in opposite. And it's because we divided by a negative that we flipped the sign. All right, guys. Great job at 52 questions. Love those of you showing up. Hopefully you're getting a lot more comfortable and no longer as nervous about the EOC. See you next boot camp.